All right, you guys, so now for this second one, okay, we have that the function f is defined by f of x equals this whole thing, which looks a little bit nasty, I'll be honest. For x, x this, and x that. So let's explain this just for a second to understand what this is telling me. So when it says this symbol here, okay, it means that your values of x are within all real numbers, okay? And if it's within all real numbers, it's basically like there's nothing weird going on. See, it includes all real numbers. There's nothing like special happening here. It's just telling you that x pertains to all real numbers. See? So from negative infinity to positive infinity, you include all numbers in between. This might be important in another exercise if they tell you that x pertains only to, for example, z, which is like a very fancy z. This would be integers, okay? And integers are -3, -2, -1, 0, 1, 2, 3, okay? So it would be whole numbers, right? And so a detail like that can be very relevant. But if they tell you it belongs to all real numbers, it's nothing you need to like be careful for, okay? But that is what this symbol says. See, it's like x pertains to like this set of numbers or whatever, okay? So that is more of an intuitive way to put it, and I'd rather explain things intuitively. The x cannot equal 2 has to do with what your fraction has, okay? And so sometimes, because of how your function is set up, there are certain values that x cannot take. There's one or two classic examples, okay? On the one hand, 0 divided by 3, you guys, is how much? Is 0. 3 divided by 0 is how much? It's undefined. You cannot divide by 0. It is illegal. Don't do illegal things. Usually, I suggest that you should not do illegal things, okay? So if you divide by 0, it's illegal, it's undefined. So why can x not equal 2? It cannot equal 2 because in the denominator, basically this whole thing cannot equal 0, right? And so 2x minus 4 cannot equal 0. And if you get x alone from here, 2x cannot equal 4, divide by 2 to both sides, x cannot equal 2. Ah, so that is where it comes from. See? That is where it comes from. X literally cannot equal, sorry, the denominator cannot equal 0, so that means x cannot equal 2. So that is one example that can sort of show up that restricts the values of x that you can take. That is one classic example. The other classic example is, for example, like a square root. See? So imagine you have x minus 3 here. The point is you cannot have a negative inside of a square root. Okay? It's unsolvable without using imaginary numbers. Okay? Which is a whole other thing that I'm not going to get into, but usually the idea is whatever's inside has to be greater than 0. And so in this case, x minus 3 has to be greater than 0, x has to be greater than 3. Okay? So that is just a made up scenario, but point is sometimes your domain gets restricted. Your domain is values that x can take. Okay? So this thing here is just helping you define your domain. It's all real values except for 2. All right? And this made up example of the square roots is something that I know can show up for you, so I'd rather tell you. Inside the square root, things have to stay positive. So greater than or equal to 0, now that I think about it. Greater than or equal to 0. Enough blah blah. For part A, we need to find the 0 of f of x. And so for finding the 0 of f of x, basically, when they ask for zeros, they are asking for the x-intercepts. And whenever you need to find x-intercepts, notice, here you have a y, here you have an x. All of these that I'm putting in red are x-intercepts. See? Now, what do they all have in common, you guys? Some of you are probably thinking, well, they're all x-intercepts, right? But what do all of these points, what do all of these x, y's have in common? Ah, all of these, without a doubt, because they are x-intercepts, have a y equals 0. So whenever you're finding an x-intercept, okay, you just need to plug in x comma 0. And on that note, if you ever need to find a y-intercept, it's the same thing but the other way around. If you ever need to find that y-intercept, notice how all of these points, what do they have in common? They have in common that their x equals 0. And so for the y-intercept, you will be plugging in 0 comma y. So your y-intercept is basically 0 comma something, while your x-intercept is something comma 0. All right? So that is a little bit of an intuition of why we approach this the way we do. Whenever they ask for zeros, it is specifically about x-intercepts. And so that is something we need to associate in our brains right away. Zeros is for x-intercepts, okay? And so we plug in x comma 0. So here we have, well, our original, right, is f of x equals 7x plus 7 divided by 2x minus 4. So if you plug in x comma 0, that means your y is 0. Now where is y? This whole thing is y. So this whole thing is now 0, so you end up with 0 equals 7x plus 7 divided by 2x minus 4. And the cool thing you can do here is that because it's a fraction, you can multiply by 2x minus 4 to both sides. And this is very useful because, this goes away with this, and anything times 0 is still 0. So you end up with 0 equals 7x plus 7. I want to get x alone, so I do minus 7 to both sides. So basically end up with 7x equals negative 7. Divide by 7, divide by 7. X has to be, for part A, x has to be equal to negative 1. So for part A, I'm just going to put it up here just to be more conservative with space. So for part A, x equals negative 1. Okay, so that is the 0 of f of x. If you get fancy, you can say that it's negative 1 comma 0. Okay, same idea, nothing is changing there. So that is for part A. Remember that zeros makes reference to x-intercepts, a very specific thing you have to remember. For part B, part I, or for part B initially, they tell us that for the graph of y equals f of x, which is basically just this, right? So for your function, write down the equation of, first of all, the vertical asymptote. Now, there's a lot of buzzwords here. So on the one hand, you have vertical, on the other hand, you have horizontal, and then you have this special one, asymptote, asymptote. Now, what the heck is an asymptote? An asymptote is basically an equation or a line. Let's think about it as a line. So it's a line that your function will never touch. Okay, that is actually such a good definition. So an asymptote is a line that your equation will never touch. Is a line that your function, better said, will never touch. And so there are different types of asymptotes, but for us, they will always be vertical or horizontal. So if I go ahead and graph this here, okay, for example, onto decimals, and I know that for this part you don't have calculators, so some of you might be thinking, oh, dude, why are you doing this? We don't have calculators, like, this is cheating. Okay, I'm only doing this so you guys understand what an asymptote even is, okay? And so if you graph your function, right, it looks like that. Okay, so you're gonna have two asymptotes, and I'm gonna show you how to find each. On the one hand, you have a vertical one on x equals 2. So notice how my red line never touches the blue one, not even close. Okay, even over here, yes, it gets very close, but it never actually touches it. Okay, so here's my vertical one, and my horizontal one is a y value. And I'm going to show you in a second how to actually get that. Okay, and so your vertical one, your vertical one is an x value of 2, the one in blue, and your horizontal one is a y value of 7 over 2. See? Now, I know some of you might be a little bit confused by this. See? For example, why is my vertical asymptote, the one in blue, an x value? Like, we have associated x values to horizontal stuff, so why is my vertical asymptote an x value of equals 2? It's an x value of equals 2 because all along the line, what does x equal? Ah, x equals 2 all along my line. And so for the vertical asymptote, you put in a fixed x value, which means that all along the line it's just 2. And for the horizontal one, it's the same idea. It's a fixed y value. It's always 7 over 2. Well, here it puts it as 3.5. See? So that is why I know it's a little bit counterintuitive, but okay, so for the horizontal asymptote, it's a fixed, for the horizontal one, it's a fixed y value. So you need to put y equals something. For the vertical one, it's a fixed x value, right? And so that is the idea of an asymptote. See? Now, how do you actually find them? Well, for the vertical one, it's a little bit easier because now we have associated in our brains that vertical, okay, is a fixed x value. And so once you find out the values of x that you cannot take, that is the equation of a vertical asymptote. And so here they actually tell you that x cannot equal 2, and the proof is the one I showed earlier, right? So you took the denominator, you said this can't equal 0, right? And so quickly you find out that x cannot equal 2, see? And so because x cannot equal 2, the equation of your vertical asymptote is x equals 2. So the moment you put x equals 2, the blue line shows up, okay? And so careful, it's very important that the equation of your vertical asymptote is x equals 2. You cannot put x does not equal 2 because this is not an equation. You need to leave it as an equation. So x equals 2 allows you to draw the blue line, okay? So that is for part B, part I. For part B, double I, you need to find the horizontal asymptote. And so for the horizontal asymptote, you would be saying it's a horizontal fixed y value. Now, for this one, it's a little bit harder to like figure it out. See? For the vertical asymptote, it's usually friendly because it has to do with, I don't know, you can't divide by 0 or something about like whatever, like it's a square root, so it has to be greater than or equal to 0. It's usually like a nicer approach. See? For the horizontal asymptote, we have to find the equation of this green line. And so the best way I can show you, and I know it's a cheap answer, but it's what works. Okay, the best way I can show you is that you just plug in a very big y value. Okay, because if you plug in a very big y value, like all the way out here, see, I don't know, let's do it like 100. See, so if you plug in like 100, okay, you're gonna end up very close to your line, extremely close. See, and so all you need to do is that it's gonna be pretty apparent what number you're close to, what number you almost reach, and that is gonna be your horizontal asymptote. See? And so for this, I know it's a little bit cheap, but basically for horizontal asymptote, plug in really big values. Okay? And so if you plug in really big values, for example, so my f of x, as we said, is 7x plus 7 divided by 2x minus 4. So if I go ahead and plug in something like, I don't know, 100, right? You end up with 7 times 100 plus 7 divided by 2 times 100 minus 4. So that means that I pretty much, okay, end up with 700 plus 7 divided by 200 minus 4. See? So this is pretty much just going to be 707 divided by 200, sorry, 196. See? Now you might be thinking, dude, dividing this is insane. It's very hard. What do I do? Right? I just came up with a smarter way to do this. See? So technically, if you have your calculator, this is a nice approach, and you're pretty much going to end up with 3.5. But doing it by hand is much harder, see? And so let me go back a couple steps, and let's keep the idea of plugging in a really big value, see? So a smarter way to do this, and again, I'm leaving it in the video because oftentimes when we do our exercises, we figure out a smarter way to do it. It's part of the process. So I'm going to leave it, okay? Because I know you go through the same stuff. So if you go ahead and let's imagine for a second that you're like plugging in, I don't know, like infinity. Okay, and I know this is kind of whack, but trust me, if you just trust me for a second. See? So if you go ahead and plug in infinity, think about it for a second. So we have 7 times infinity divided by plus 7 divided by 2 times infinity minus 4. And so when you have infinity going around, which is just a massive number, right? It's just a crazy massive number. And this is not actually how infinity works, but for us intuitively, for the vertical asymptote, for the horizontal asymptote, it's going to help. See? So just think about it as 7 times a massive number plus 7 divided by 2 times a massive number minus 4. How much effect do you think these numbers are going to have? Nothing. They're going to have no effect because they're next to a massive number. So really, you can just think about it as this, right? Once you plug in infinity, the 7 and the negative 4 don't really matter. And so technically, what you're really looking at is at 7 over 2. And so the equation for the horizontal asymptote is just going to be 7 over 2. Okay? Technically, it also works doing the thing I did by times 100, right? Or you can do it like times a million and then divide and actually figure it out, and you will end up with 3.5, okay? Or you're going to end up with 3.4999999. But for me, maybe more intuitively, it makes sense to do this approach. See? I know it's kind of whack to plug in infinity, but I just used it as an idea to, like, you're plugging in a very big number, and so once you plug in a very big number, this and this is irrelevant. And that's the whole point, because you're going way out in your function, way out to the right, and the 7 over 4 just doesn't matter at that point. So it doesn't matter at that point, and that gives you a green line very close to the red one, and that is the equation you want. See? So again, that was a little bit of a cheap way to do it, but for horizontal asymptote, it tends to be like that. It tends to be plugging in a very big number, and usually with a little bit of imagination, you can get there much quicker. See? So there it is for part B. Last but not least, for part C, we need to find that, which they tell us is the inverse function of f of x. Now, for finding the inverse, thankfully, it is a very sort of straightforward approach, okay? And so, before anything, the inverse is like the mirror of your function, okay? And so, for the inverse, the steps are going to be always the same, see? And this is just the steps I suggest. I know there are others, but these are the steps that I suggest. So, the steps that I suggest is that first you write down the OG. So put the OG. The OG function, the original function. Okay? So put the OG. Then put f of x as y. And so now I haven't done anything yet besides just putting f of x as y. And now the third step is going to be flip x and y. And this is the key step. The moment you flip x and y, you're now finding the inverse. See? So if you flip x and y, that means you end up with x on the left equals 7 times y. Ooh la la. Plus 7 divided by 2 times y minus 4. And now that you flipped x and y, get y alone. Okay? So if you get y alone from here, well, again, because it's a fraction, I highly suggest that you multiply both sides like this. And so this first step of multiplying is usually going to be like that. So on the left side, you end up with 2yx minus 4x equals 7y plus 7. Now, because our mission is to get y alone, put all the y's on one side. So I'm going to do minus 7y minus 7y. That means I end up with 2yx minus 7y minus 4x equals 7. And so now you want to get y alone, so you do plus 4x plus 4x. So 2yx minus 7y equals 4x plus 7. And so from here, now that you have all the y's on one side, see? So notice how here you had a fraction, so you needed to multiply, right? Over here you had the y's on both sides. And now, once you have all the y's only on one side, you can factor. And so if you factor on the left side by y, that means inside, like if you take y out from each, you end up with 2x minus 7. Ah, interesting. And so now to get y alone, right, you can just divide. So here, because it's multiplying, you can divide by 2x minus 7 to both sides. So that means that this goes away with this. You end up with y equals 4x plus 7 divided by 2x minus 7, right? And so now that you got y alone, your last step, just to be very organized, is put the inverse, or put y, sorry, put this new y as the inverse, see? And so this is just to be very rigorous in your approach. So you're just going to change the symbol here. So your inverse function is going to be this, see? And that is for part C, right? Now, the last step you have to do is that, okay, you need to put the detail, okay? You need to put the detail that the denominator cannot equal 0, right? So what value can x not take? Well, the value that x cannot take is that your new denominator cannot equal 0. So this cannot equal 0. So plus 7 to both sides. 2x cannot equal 7. So that means that x cannot equal 7 over 2. And so your final answer is putting the detail that x cannot equal 7 over 2. And that is for finding the inverse. See? So again, a little bit of an annoying process, but it's always the same. The big step you have to do is step number 3. Okay? Anyways, you guys, that is for number 2, and I hope it helped.